solve a problem on how to sketch the polar plot of a system when its open loop transfer function is given to us. So let's take a problem. So our problem is to sketch the polar plot for the following transfer function, and the transfer function is given to us as gs equals to 1 upon 1 plus s and 1 plus 2s. So let's try to solve this. For sketching the polar plot, the first step is to replace this s by j omega. So first step will be put s equals to j omega. Now just check that it is given to us in 1 plus st form, the transfer function. Here t is equals to 1 and here t is equals to 2. So it is already given to us in 1 plus st form. So we need not to change it in this form. It is already given to us. So just replace this s by j omega. So it will become j omega. Okay, we have just replaced this s by j omega. Now second step will be to find out the magnitude and the phase angle of this gj omega. So magnitude will be, it is given by m and it can be calculated by this. Now let's find out this magnitude. It will be 1 upon under root of 1 plus omega square under root of 1 plus 2 omega square. So it will be 1 upon under root of 1 plus omega square and under root of 1 plus 4 omega square. Okay, so this is the magnitude of gj omega. Now let's take out the phase angle. Phase angle will be, it is given represented by phi, and it is the phase angle of gj omega. So it will be, because in the numerator part what we are having, tan inverse of imaginary part is 0 and real part is 1, minus tan inverse of imaginary part is omega, real part is 1, so omega upon 1, minus tan inverse of imaginary part is 2 omega and real part is 1, so 2 omega by 1. So phase angle, it will become phase angle, that is phi, it is tan inverse of 0 upon 1, it will be tan inverse of 0, that is 0. So it will not be considered here. Minus tan inverse of omega upon 1. So it is minus tan inverse of omega. And then we have minus tan inverse of 2 omega upon 1. So it is minus tan inverse 2 omega. So this is the phase angle of gj omega and it is the magnitude. Mark it as first equation and it is as second equation. Now we have to calculate the value of magnitude and the phase angle for different values of omega. We will vary the omega from 0 to infinity, and for these various values we will find out the magnitude and the phase angle. So let's form a table. So this is magnitude, phase angle, omega. Let's start taking from omega equals to 0. So when we take omega equals to 0 and put its value here, then it will be 1 upon 0 and it is also 0. So magnitude will come out to be 1 upon 1 plus 0, that is 1, and 1 plus 0 here, that is also 1. So magnitude will be 1. And here putting omega equals to 0, so tan inverse of 0 minus tan inverse of 0, so it will be 0. So phase angle is 0 degrees. Now taking the value of omega as 1, so it will be 1 plus 1 and here also 1 plus 4. Okay, so 1 upon under root of 2 plus under root of 5. So the magnitude will come out to be 0.32. Here minus tan inverse of 1 minus tan inverse of 2 because omega is 1. So the angle, it will come out to be 108 degrees. Next, taking the value of omega as 2. So putting here 2 in the phase and the magnitude equations, that is equation 1 and 2. 1 plus 2 square, 1 plus 4 into 4. So when we solve this, the magnitude will come out to be 0.11. Here putting omega equals to 2, so minus tan inverse of 2 minus tan inverse of 4. So it will be minus 130, it is minus 108, this is minus 139.4 degrees. Now next, taking the value of omega as 5. Now in putting here 1 plus 5 square, 1 plus 4, 5 square. So 4 into 25 and here 1 plus 25. So the magnitude, when you solve this, you will get the value as 0.02. Putting here in phase angle, minus tan inverse of 5 minus tan inverse of 10, then phi, the phase angle, it will be minus 163 degrees. Now take the value of omega because omega is varying from 0 to infinity. So now take the value of omega as infinity here and calculate the magnitude and the phase angle. So 1 upon 1 plus infinity, 1 plus infinity, it will be 1 upon infinity, that is 0. In phase angle, if we put here minus tan inverse of infinity minus tan inverse of infinity, that is minus 90 minus 90. So it is minus 180 degrees. So for the various value of omega from 0 to infinity, we have calculated the magnitude and the phase angle. Now polar plot is what? It is the plot of the magnitude and the phase angle on the polar coordinates, as the omega, it is varying from 0 to infinity. So let's plot the polar plot for this system. This is plus 90 degree, minus 90 degree, this is 0 degrees and minus 180 degrees. So our first point, that is the first value of omega, was for omega equals to 0. Let us first divide this scale, that is the horizontal scale, on magnitude, because we are going to plot the magnitude on this axis. Okay, so this is 0, it is divided 0 0.2, 0 0.4, 0.6, 0.8, and this is 1.0. Divide on the right hand side also, 0 0.2, 0 0.4, okay. So for omega equals to 0, we are having the magnitude as 1. So it will start from here. and this is for omega equals to 0, magnitude is 1. And for omega equals to 1, the phase angle is minus 108 degrees. Okay, our table was here. For omega equals to 1, the phase angle is minus 108 degrees. So this is minus 90. So minus 108 will be somewhat like here. And the magnitude is 0.32. So 0.32 will be somewhat here. And this is minus 108 degrees. Now we have for omega equals to 2, the phase angle is minus 139.4 degrees. So minus 139.4 degrees will be here. Because negative phase angle, it is measured clockwise in the polar plots. If we are having positive phase angle, then it will be measured anti-clockwise. That is starting from here. If we measure here, then it is plus 90, plus 108. Anti-clockwise, we are going to measure it. 0 degree, 90 degree, plus 180 degree. And negative phase angle, it will be measured anti-clockwise. That is minus 90 degree, minus 100 degrees, 180 degrees. That is clockwise. So this was minus 139.4 degrees for omega equals to 2. This was for omega equals to 1. Okay. Now for omega equals to 5, we are having the phase angle minus 163 degrees. So it is like here. Minus 163 degrees for omega equals to 5. And the magnitude is 0.02. So it is here. And for omega equals to 2, the magnitude is 0.11. So this is here. And for omega equals to 1, it is 0.32. So 32, it is somewhat here. So just to join these points. This is 3, 2. And for omega equals to infinity, the magnitude is 0 and the phase angle is minus 180 degree. Minus 180 degrees here and omega magnitude 0 is here. So this is omega equals to infinity. This point is for omega equals to 5. This point is for omega equals to 2. This is for omega equals to 1 and this is for omega equals to 0. So we have joined all these points and the plot which we have got is the polar plot of the transfer function whose open loop transfer function of the system whose open loop transfer function is 1 upon 1 plus s, 1 plus 2s. This open loop transfer function, if you are not given in the question, because polar plot is plotted for a closed loop transfer function, but here open loop transfer function is given to us. It is not given in the question that what is the value of hs. Closed loop transfer function is gshs. Okay, and open loop transfer function is gs. It is not given to us in the question that what is the value of hs, so you have to consider this gs as the closed loop transfer function. Okay, and for using this transfer function only, you have to plot the polar plot of the system. So don't get confused. You have to use this transfer function only, and using this transfer function you have to plot the polar plot. So this is the polar plot of this problem, and I hope you have understood this problem clearly. Thank you.